All right, so now we're moving on to one-way ANOVA. So again, you should already have the data set codebook and syntax open. And we're going to start with theism. And this time we're going to choose a variable with at least 3 groups to compare. Now, the more groups that you have, the more categories that you have, the more comparisons it's going to make. It's going to get more complicated. So it's easiest with 3, easier with 4, etc. And as you add more categories, it gets more difficult. So if we were to look at our code book, again, it's not like a 2-sample t-test where I get to like choose my codes. If I wanted to only use some categories, I'd have to recode into a new variable that only has those. So for example, if I chose race in 4 categories, I'm going to have 4 groups, right? And these are the 4 groups that we compare. So we're thinking about for theism, what do we want to make a comparison for? And so like here, this one would work like age in 3 categories. We could do something like this one. We could do class. Why don't we do, we could do degree, so it's education. And you can't do this, there's only 2 categories. We're looking for one with at least 3. And this is like too many and it's not really categorical. It's more kind of continuous-ish. You could do marital status, but this is going to have 5 categories, right? So it's going to be a lot more to kind of sort through. All right, why don't we go with age 3 cat and then why don't we also try it with education with the degree variable, or we could do political party, right? This is 3 categories or 3 categories, depending on how you want to kind of separate it out. I wouldn't want to do this one. This is 8 categories. That's going to be too many. Okay, so I'm going to use, what was it? We'll use degree, which has 5 categories, and we'll do age 3 cat. You only need to do 1, but I want to show you both. So I'll show you one with 3 categories and one with 5 categories. Okay. So why are we using ANOVA rather than a 2-sample t-test? Again, a 2-sample t-test is comparing 2 groups. And here we have 3 different age groups. Here we have 5 different degree levels. And so if it's more than 2 groups, you have to use a one-way ANOVA instead of a 2-sample t-test. So a 2-sample t-test is only for comparing 2 means, and here we're comparing more than 2 means. So a research question would be something like, do US adults of different ages have different average levels of theism? Or right, do people with different educational levels have different average levels of theism? Or if we looked at the hours worked last week, do US adults in different kind of age categories have different numbers of average hours that they work in a week? Or do people with different educational statuses have different numbers of hours that they work on average? Okay, our null and alternative. So again, our null is that there's no relationship. And so for ANOVA, you can see that it's written out this way, right? All the population means are equal. So, I mean, you can write it with this if you want, but my null is that for age, right, that if I go back to what is age 3 cat? So the mean level of theism among 18 to 39-year-olds, 40 to 64-year-olds, and 65-plus-year-olds are all the same, right? They're all equal. So it's, and again, I could write it if I wanted a different way. So I could say, just going to copy that null. The null hypothesis is, right, that, let's see. So the mean for the 18 to 39-year-olds is the same as the mean for 40-64, is the same as the mean for 65 plus, right? Or I could say the mean level of theism for, again, those with, for degree, it would be those with less than a high school degree, those with a high school degree, associate, junior college, bachelor's, and graduate are all equal. So I'm saying the mean for my dependent variable, whether it's here theism or whether it's the hours worked last week, is the same for all categories. Okay, and then my alternative is that they're not all the same. So this is where it's a little different than a two-sample t-test, right? So if we reject our null and accept our alternative, this is just that they're not all the same. It doesn't mean that they're all different, and we don't know how many are different. It's just that at least one of them is going to be different from another one. So it's that the population means are not equal. So not all of the age groups have the same mean theism. Levels of theism. Or not the people the mean levels of theism for people with different education levels are not all equal, right? Or again, like the average number of hours worked last week is not going to be equal among all three age categories. Right? I could add at least one age group will have a different mean level of theism than at least one other age group. Okay, so again, this is that they're all equal. This is that they're not all equal, but it just means at least one is different from another. They could all be different. It could just be one that's different. We don't know. Okay, now I'm going to run ANOVA. So in my syntax, I have it right here, part 2, problem 3 ANOVA. That should say construct. So you're going to put your dependent variable in where it says ratio variable name, right? That's the one that we're going to have means for. And so in this case, that's theism. And then my grouping variable name, I have age 3 cat. Why don't I just do the other ones I want to do as well? So we have 3 that by degree, and then we can also look at this with the hours worked last week. Let me make sure that rating's still on. Let's just see if these match or not. 794 4.2 versus 794 4.2. Yep. Okay. So I had waiting on. Great. Okay. So here's my syntax. And here's my output. I have my descriptives. Oops. Switch to ANOVA. And this means plot, which I like to get rid of that line. I don't really like it because it applies kind of movement, which doesn't make a lot of sense for categories in the same way. I'm just gonna change this. You don't have to do this, but and I'm actually just gonna change. You don't have to change this, but I'm also gonna change. Theism was, what was it, 1 to 7? That way it won't show kind of these differences as exaggerated. Let me just make sure. What was it? Yeah, 1 to 6. Okay. Hmm. Okay, I like that better. So as you see there, when I click on, I have copy as image as an option. And so if I do that, instead of taking a screenshot, I can literally just paste it, which is nice. Okay. So if I wanted to do this using drop-down menus, I'd go analyze, compare means, compare means and proportions, and I choose one-way ANOVA. I put my dependent variable into the dependent list. So that's the ratio level one that we're doing the means for. So for example, another one I could do, let's see if this one is. So like poll views from 1 through 7, I could choose to do that. And then my factors, I'm going to split it up. So let's say I used H3 cat as my different groups. Put that into the factor one. And then here I also have to, I don't need anything here. I'm not doing post hoc tests. You read about them, I believe. So this is like, if you want to do a certain test to see which groups are different from others, we're just going to look at confidence intervals for that. But here I'm going to add descriptives and I'm going to add my means plot. And this is going to give me my sample means and confidence intervals for each of those groups, because that's not actually part of the ANOVA test. It's just descriptive sample statistics. And then this is going to give me that nice little graph, which just helps me picture where the sample means are. Okay. So it says, what are the sample means for each of your group? How do they compare? And also discuss whether certain ones are more or less theistic and how much more or less theistic they are. So if we look at these sample means, they're all basically between 4 and 5, right? We can see 4.2, 4.94, and 4.95. So 18 to 39-year-olds, 4.2. 40 to 64 are 4.94, and then 65 plus are 4.95. So I would say that the 40 to 74-year-olds and 65 plus year olds are almost identical, right? They're like 1/100th apart. The 18 to 39-year-olds have slightly lower theistic beliefs. So a 4.2 is kind of just above the sometimes, and a 4.94 and 5 are basically almost at this. So well, 18 to 39-year-olds are a little more theistic than sometimes believing in God. Their older counterparts are almost at believing with doubts. Okay. If I were to look at these other ones, so if we look at this one by education, okay, we can see that the most theistic are less than high school, and associate junior is pretty similar. High school is a little lower, but still leaning towards the 5. And then bachelor's and graduate are closer to the 4. So again, all within the 4 to 5 plus range. But we can see that folks with a college degree or higher are closer to the kind of that sometimes believe, and folks with less than a college degree are closer to that believe with doubts. If we look at, and again, I could also look at the exact sample means right here for that. If I look at the hours worked last week, we can also see here that the middle group, right, is working the most hours, so over 42 and a half hours. The youngest group is working less, around 38 and a half hours, and then the oldest group is working the least at like 31 and a half hours. And there's a spread of over 10 hours between these two groups. Here we're looking, what's that age again? Oh, I did age twice. I think the other one I wanted to do was the education, right? So let's look at that. Yeah, I didn't touch that. Here we can see as education goes up, number of hours worked goes up. Again, only like a range from 39 to like 42 and a half. And we can see it's right. It's not entirely considered. There's not much difference between an associate and a bachelor's degree here, but going from less than high school to high school is about an extra hour. High school to some college or college is another hour, and then some college or college to a graduate degree is another hour and a half. And we can see from here to here is over 3 hours. So as education increases, we're seeing an increase in the number of hours worked, but all within this 39 to 43 hours range. And lastly, I added in this politics one. Here. So this one was poll views, right? And so this is 1 to 7, going from extremely liberal to extremely conservative. A 4 is moderate. So we can see that 18 to 39-year-olds are leaning liberal. And then the middle and higher category, all between 4.2 and 4.3, they're leaning conservative. Let's get rid of that line too. So again, they're not hugely different, their averages, but we can, especially now that you can see the whole scale, but if this is moderate, we can see the younger folks are leaning liberal and the older folks are leaning conservative. And these two aren't very different. And we can see that here as well, right? 3.84 versus 4.21 and 4.29. Okay. So next it asks us what our p-value is, what that means about our null and alternative hypothesis, and then to explain it in real life context. So let's go back to our original one. And so here's the ANOVA test. And this is all of those calculations that were in the textbook that was talking about that produces an F statistic, and then we get to our p-value, but here's the p-value. So this is what you need to look at. So p is less than 0.001. Because p is less than 0.05, we can reject our null and accept our alternative hypothesis. This was the same percentage as in the last one, right? So if I do 100% minus 0.1%, I get 99.9%. Because it's not equal to, but less than, it's going to be greater than when I've subtracted that. So I'm going to say I'm over 99.9% confident that, and then I'm going to look at my alternative hypothesis, right? That not all of the age groups have the same mean levels of theism. Right, so at least one of those three age groups has, I'm over 95% confident. In fact, I'm over 99.9% confident, but in terms of significance, I'm over 95% confident. That's what means I'm significant. It's significant that among my target population, right, among all US adults, not just among this sample, but among all US adults, that they don't all have the same average theistic beliefs. Among US adults in 2022. Okay. If we look, let's look at the other ones. So here is also p-value less than 0.001. So we're saying that education, also not all of these groups have the same mean. We're over 99.9% confident that among all US adults in 2022, that education levels don't all have the same mean level of theism. We can see for this one, same thing, right? We're confident these aren't all the same means for hours worked. That's what our p-value is. Here's one that's, okay, so this one is hours worked and degree. Okay, and so for this one, we see it's 0.085. So our p-value is not less than 0.05, and so normally we would say that we can't reject our null. Sometimes people use a significance threshold of 0.1, right? So we could call this marginally significant. And so that's kind of a judgment call. Traditionally, you would say this is not significant, in which case we would say, right, like p equals 0.085. Because p is not less than 0.05, we cannot reject our null or accept our alternative hypothesis. And so we're not over 95% confident that the age groups, is this age, sorry, education levels, that US adults of different degrees don't all have different what is this? Is this hours average number of hours worked last week? Right. So our null is that these all of these groups work the same number of hours, and we can't be over 95% confident that that's not true, that on average last week these groups work the same number of average hours. Now it is marginally significant. So if you wanted to, you could decide if p is less than 0.1 to say, you know what, we have some evidence to reject our null. If I want to calculate this, so 0.085 is 8.5%, right? I'm just moving the decimal over twice or multiplying this by 100. And so I do 100% minus 8.5%, and that would give me 91.5%. And so I am over 5% confident that, and that's where I would go to my alternative hypothesis, right? That among US adults in 2022, not all education levels work the same mean number of hours last week. So at least one of these degree levels would be different than at least one of the others. So if it's less than 0.1, again, traditionally you reject if it's not less than 0.05, but in some cases people use 0.1 as a threshold instead, or you can call that kind of marginally significant or approaching significance. But again, if it's not less than 0.001, you can do this calculation. So if I did have something like p equals 0.02, which is 2%, right? I would do 100% minus 2%, and I would say I am 98% confident, right, that I can reject my null and accept my alternative hypothesis, okay, that among all US adults in 2022, right, all the groups don't have the same mean. Okay. What are the confidence, was it the last one? Yeah. What are the confidence intervals for each group's means? So for each group, list them. And so this is going back to these confidence intervals. So for 18 to 39-year-olds, 40 to 64, and 65 plus. And so here's my confidence intervals. So this is 4.07 to 4.32. That's my lower and upper bound. 4.84 to 5.03, and 4.80 to 5.09. This last one where it says total means for all respondents, right, across all age levels. So that's not a group that we're comparing, that's just the overall group, which you could compare to kind of where the rest are, right? So like this means that here, and you can see how much more or less these are, but we're not including this when we're looking at the group's means. Okay, interpreting them in real life context. So these are 95% confidence intervals. And so I am 95% confident that the mean theistic belief among 18 to 39-year-old US adults in 2022 was somewhere between 4.07 and 4.32. Meaning they were a bit more theistic than the 4, which is than sometimes believing in God. Okay, this one, it's similar. I am 95% confident the mean theistic belief among 40 to 64-year-old US adults in 2022 was somewhere between 4.84 and 5.03, meaning they were about or just under the level of theism of believing in God with doubts. And lastly, for this group, this is basically the same as that. And so I'm just going to change this to among US adults 65 or older. And I'm changing this, but my interpretation can be the same. Okay. If I were to look at another one, here, again, I'm looking at each of these and interpreting them. But let's look at the hours one. So here, like I'm 95% confident that in 2022, US adults aged 18 to 39, if asked the number of hours they worked the last week, would answer an average that would be somewhere between 37.6 hours and 39.3 hours, right? Or if for 65 or older year old, if I ask this, right, among all US adults that age in 2022, the average would be somewhere between like 29 and 34 hours. Okay. So now it says which means are significantly different than the others. Okay, so I'm looking at these, and this is just like before when we were comparing groups and looking at confidence intervals and seeing if they overlapped in chapter 6. We had the confidence interval of the difference for the two sample t-tests, so we didn't have to really do this. But for here, we're comparing the different groups. So we're going to compare 18 to 39-year-olds to 40 to 64-year-olds. We're going to compare 18 to 39-year-olds to 65-plus-year-olds. And we're going to compare 40 to 64-year-olds to 65-plus-year-olds. And so we're going to see whether these confidence intervals overlap or don't, to see whether they're significantly different from one another. So this is, again, at the 95% confidence level. So we're seeing whether or not they overlap. And you can see here now why, if you had 5 groups, for example, you'd have more work to do because you have more groups to compare. So if I take 18 to 39-year-olds and 40 to 64-year-olds, I can see that this one at most is 4.32, and this one at least is 4.84. So these don't overlap. So this group is significant. Okay, 18 to 39 and 65. Then this one at most is here. You can draw these out if it's helpful. This one at least is here. These don't overlap. So that's significant. And then the last one, this one's actually starts out lower. This one goes up to 5.09, and this one starts down at 4.84. So these do overlap. Because, right, they could both be 5, for example. They could both be 4.84. They could both be 5.01, right? And so these overlap. So 18 to, my answer is that 18 to 39-year-olds are significantly different from both 40 to 64-year-olds and from 65-plus-year-olds. 40 to 64-year-olds are not significantly different from 65-plus-year-olds. Now, if I were to do this with another group, where I have more of them, so let's say I wanted to do it with this one, I have to compare less than high school to high school, less than high school to associate junior, less than high school to bachelor's, less than high school to graduate, high school to associate, high school to bachelor's, high school to graduate, associate junior college to bachelor's, associate junior college to graduate, and bachelor's to graduate. So there's, again, as you have more categories, there's a lot more comparisons to make. We can see here, again, the lowest one, graduate, 4.15 to 4.57. So let's see, 4.57. This one is significantly different from associate junior college, high school, and less than high school, right? All of these are starting out higher than the top here, but it's not significantly different than bachelor's. We can see these could both, for example, be 4.2 or 4.5. Um, Same thing, bachelor's, we just know from what we just did, right, is not significantly different from graduate. It goes up to 4.52. It's significantly different than all three of these. If we look at high school, 4.63 to 4.83, it is significantly different than both of these. It's significantly different from all of them, all the other ones. We can see again when we get to asking about substantive later, right, that these might only be 0.03 apart. So it might not be that meaningful, right? We're not confident that it's substantively different, but they are significantly different because all significance means is we're over 95% confident that the means are not the same. Okay. And again, I could keep going through these, but you get the idea. Okay, so now it says which are substantively different or not. And for groups that are significantly different, show how close they might be. Okay, so if we just look at these groups again, so we know that the 40 to 64-year-old, sorry, the 40 to 64-year-olds and the 65 plus year olds were not significantly different. So this one is not substantively different, right? Because they could be the same, right? It could be zero different. So again, these overlap. These two don't overlap. They are significantly different. And so the question is, we're 95% confident they're at least how different. So the closest they could be are these. So this would be 4.84 minus 4.32, which gives me 4.5, sorry, 0.52. So we're 95% confident that this one is at least, right, half a unit on that 1 to 6 or, yeah, 1 to 6 scale. And then here, 4.80 minus 4.32 equals 0.48. And so both of those were 95% confident they're at least about half a unit apart, which I'm going to argue is substantive because, again, this is only a 1 to 6 scale. And so I think that that's significant. You could argue against that. And again, depending on the scale or other things, you could argue differently. But this is how close we're confident they're at least this far apart. This is how close together they might be. They might be further apart, right? Like this one could be 5.03 minus 4.07, which would be, I think, like 0.96, right? So they could be further, but we're 95% confident they're at least this far apart on average. So I'm arguing that these are substantively different. Again, the example I was just showing you before of the education one, where high school and less than high school are significantly different, but they're only 0.03 apart at the 95% confidence level. Again, they could be further apart, but we're only confident they're at least that far apart. And so I would argue that's not substantive, right? I'm not over 95% confident that the difference is sizable. So again, for this, for any ones that are significantly different, I would evaluate how close together might they be, and then is that a meaningful difference on the scale I'm looking at? If I looked at number of hours worked, for example, let's see, 28 to 34, 37 to 39, 42 to 43, none of these overlap, right? They're all significantly different from one another. This one goes up to 34. This one starts at 37 and a half. So these are at least 3.5 hours apart. And then these two are at least 3 hours apart. And then these two are at least 8 hours apart. And so I would probably argue that that's substantive as well for, how many hours you're working in a week. Okay. Do you think that there's a causal relationship justify using all of these? So we're saying, does age influence your level of theism? So again, we were saying, so it doesn't need to be that all of them are different. What we're saying is that younger adults are a little less theistic than older adults. So, sure, why don't we go with yes? So it was significant, substantive, okay, now we need causal order. So if you believe more or less in God, that's not gonna change your age, right? So age comes first, so the causal order is correct, right? Um, Theism is not going to change your age, but age might have an impact on your beliefs. So what impact might that be? So maybe I don't know. Again, this can just be kind of offhand. Maybe older people are more set in their beliefs, and younger people are more likely to be questioning. I don't know. But again, we need some reason that explains why we had this finding. And then finally, non-spuriousness. I could not think of a preceding variable that would explain away the relationship. Okay. Again, not much comes before age. I'll show you an example of one where maybe you could argue it was spurious. So if we looked at this liberal or conservative one, okay, so we could say maybe it is same argument, right? Older people are more kind of set in their ways. They have a more, or maybe they're more conservative. And maybe we'd say that's because, I don't know, as you get older, your idealism fades or something like that. But you could also think maybe you could also argue that this could be spurious. Maybe it's not about age and it's about generation, like when you were born, right? And so maybe folks that are 18 to 39-year-old had formative years during things that made them more liberal, and older folks were born into times that made them more conservative. And so it wasn't actually that, as you like, these folks, when they get older, will still be more liberal. And these folks, when they were younger, might have still been more conservative, right? We could test this out. We could, but that's an example of something that could make it spurious. If we're saying it's not that age, how old you are is impacting it. It's that when you were born, is impacting how liberal or conservative you are. And when you're born also impacts your age, right? And so it's explaining away that relationship between age and how your political ideology. So you could argue that this is or is not spurious. If you said it was spurious, then you'd say the relationship's not causal, right? If there's a preceding variable, one that comes before your independent variable, before this categorical variable, that explains it away. So here, again, if we were going to argue that this is causal, you'd have to come up with, right, you think about causal order. So again, education makes sense that that could influence your beliefs about God, whereas, there might be some people who, based on their beliefs, level of belief in God, decide to or not to pursue higher education. But in general, I'd say it's more going to be this direction. And we're seeing that folks with more education, this is the theory, right? Folks with at least a college degree are a little bit more questioning than folks without, right? And so that might be a nature of kind of additional exposure to the world and different belief systems, which can cause you to question your own, just more openness to um, to question things, as opposed to maybe more traditionalism in the community you're in, or not being exposed to as many different beliefs, right? So we could think about something like that as a theory. Here we could think about, right, like this is the prime years for working, right? Maybe let more folks are students or not working during this time. Folks here are retiring. And so we could also explain again what's happening here. That is ANOVA.